Let's look at problem number 3. Okay, problem number 3 says evaluating expression. So now we have actual expression here, and they're going to give us some letters to fill in. So first thing you need to do again is understand that this is the first, that's being cubed, just the s, and the t's being squared. And then the second thing is you have to remember, as I said earlier, you need to really focus on using the parentheses. So because my s is being replaced with 2, I put the 2 entirely in parentheses and then put the cubed. And then I'm going to do the same thing with my t. Now it's very important, especially when we come up with negative numbers. We'll see that in a second. So I get 2 cubed, which is 8. It's still multiplication. Right here, now if I would have just written negative 3 to the second, this is really negative 9. Okay, but since I put negative 3 in parentheses and then squared, that is saying negative 3 times negative 3, which is actually positive 9. Where this one, following PEMDAS, says 3 times 3, which is 9, but then make it negative. Okay, so that's the importance. That's very much the importance of working through the PEMDAS and using parentheses in these problems. Okay, so once we're here, we're just going to multiply. Okay, we're going to take 3 times 8, get 24 times 9. Okay, 9 times 4 gives you 36. 9 times 2 is your 18, giving you 216. Okay, so our answer would be 216. Alright, so got it, number 3. Again, pay attention to what's being raised to what power, and make sure that you're using parentheses when you enter in values. Okay, so let's look at problem number 4 here. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by an expression 1000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Okay, so they actually just gave us the formula here, so you don't really have to do much thinking or constructing on the formula. Now they told you kind of this is what the setup, this is what it would look like in a written way. They want you to evaluate when h is 0. So we're going to go first and do 1000, 2 raised to the 0. Now again, 2 is being raised to 0, so that makes it 1. So we have 1 times 1000. That gives us just 1000. Okay, we're going to do the same thing except when h is negative 3. So I'm going to take 1000 times the negative 3, or excuse me, did that wrong, didn't I? Okay, times the 2 raised to negative 3, that's what I meant. And what we get here is we get 1000, but then we have 2 raised to negative 3, which really becomes over 1000 over 2 cubed, which is 1000 divided by 8. Okay, so now that I take 1000 divided by 8, I get 125. Okay, so we want to know what these things are. What does this mean for our answers? Well, the first one here, 1000, is when h is 0, which they said is the hours after a scientist measures. Well, that means that that's right when the scientist measured that. So the initial population would be 1000. But then negative 3, what's that mean? Well, that's negative 3 hours before the scientist measured. So that means it's actually going back in time. And I know we usually say negative hours doesn't work. But this would be saying that's the population size before the scientists even got there, which would be 125 bacteria, spores, or whatever it was. Okay? So just kind of plugging through and understanding what those numbers mean. Here's the examples and the got it's that we did. So check your work on that. And take your Edmodo and quizzes in class, and we'll see where you're at.